In today's video, I would like to introduce a very nice problem of Brazilian Mathematical Olympiad edition 1997. Here is the following setup. Determine all positive integers x, y such that we have x strictly superior than 1 and all primes p and q satisfying this equation. Okay, p to the x equals 2 to the y plus q to the x. In fact, this is very nice and interesting problem to work on. So the hint that I'm trying to give to this problem, so if you take a look carefully, we have the both primes. If we take the difference of these two numbers, is giving you the even number. Okay, so in the other word is giving you the power of 2. So this is the good thing. The not good thing, we have a lot of unknown variables here. We don't know p and q, we don't know x and y. We are going to study the status of these variables. So another nice thing here, when you take the difference of these two numbers, is giving you a clear image what's the power of this difference, p and q. Okay, so I would be recommend to give the try to this problem pre-looking to the solution. By the way, don't forget to support us with your like and subscribe. Now let's go ahead jump into the solution. So we have the following equation. The first thing, I'm going to move over this q to the x to the left hand side of this equation. Now we are going to check the status of x. What's the parity of x? So let's break this one into two cases. So when we have x as an odd number first, then we check when we have x as an even number. If x is an odd, we don't need to work on y here, we need to work on x, because if you take a look, if this one is taking the even number, it will have the difference of 2 squares. That's our goal. Before we check the case when we have x as an even number, we are going to check when we have x as an odd number first. When we have x as an odd number, this one is become factorable polynomial. So, and the second thing, be careful, we have x strictly superior than 1. So that's mean the odd number of x is start from a number 3. Okay, so this one will be written on this form. P to the x minus q to the x is giving us p minus q factor p to the x minus 1 plus q is multiplied by p to the x minus 2 and all the way down to the last term, q to the x minus 1. The entire thing equals 2 to the y. Equals 2 to the y. Here where is x is strictly superior than 1. Okay? Now the nice thing here, the right hand side of this equation is a power of 2. That means the left hand side of this equation is a power of 2 as well. So we know this term is even because the difference of two primes is given as always even. Okay, but the only thing which we're concerned about, if this one is even, is a problem, because if it's even, it means it has a prime factor inside of this one. Okay, but if it's odd, we are fine. The all power goes towards this one. If you take a look carefully, these terms represent the number of the error here. Okay, since the exponent is odd, that means the number of the terms must be odd as well. And also, if you count, this one is giving you odd terms, not even terms, because we have exponent is odd. Okay, and in addition, every individual term is odd, because this one is odd. When you raise the power of this one, is always giving you odd. This product is giving you odd because the product of two odds is giving you odd, and so on and so forth, all the way down. Since if you group first term and second term, is giving you even, and keep going like this, and keep going on this pattern, and all the way down, you will be left with one more. So we'll have even plus one odd. Okay, so we'll have odd terms. Here you have odd terms. That means this expression is odd. Okay, let's take the concrete example. For example, if we have 19 cubed minus 3 cubed, if I'm going to factor this one on the form of the product, we will have 19 minus 3 factor 19 square minus 3 is multiplied by 19 square plus 3 square. So this is even, this is odd, with this odd become even, plus odd is giving us odd always. So the same thing with this one. Okay, So that's mean the whole power is going towards even power. Okay, so this means this one equals to this one because this one is an odd. Okay, this one is in Italian as P minus Q, is taking the whole power of evenness to the y. This one is Italian as this expression is taking number 1. But the problem, we have x strictly superior than 1. Since x starts with number 3 because as an odd, that means we will have 3 minus 1, which is 2. I will have p squared here. Okay? Regardless of the addition terms. So this when this is a large number. This is contradiction. Okay? That means we have no solutions. No solutions when we have x as an odd number. Okay? Let's move on to the next case when we have x is an even. When we have x is an even. When we have x is an even, that means x equals to n. Let's set x equals to n. Okay? Now I'm going to replace x with 2n in this equation. So we'll have p to the 2n minus q to the 2n. So this one is written in the form of the difference of two squares. I'm going to factor this one out since we have the minus sign here. So we'll have p minus q, p to the n minus q to the n, factor p to the n plus q to the n equals 2 to the y. Now, since the right hand side of this equation is a power of 2, that means the left hand side of this equation is a power of 2 as well. So we'll have p to the n plus q to the n equals 2 to the b, and we'll have p to the n minus q to the n equals 2 to the a. Okay, where is b strictly superior than a? Because this term is bigger than this term. Okay, so now I'm going to subtract this equation from this equation in order to get p to the eliminator. Okay, so we'll get here 2 times q to the n. By taking this difference of these two equations, I will have 2 to the b minus 2 to the a. Okay, since a and b are positive integers, I'm going to divide both sides by number 2. So we'll have q to the n equals 2 to the b minus 1 minus 2 to the a minus 1. Okay, here is the thing. The left hand side of this equation is an odd because we have prime here, but the right hand side of this equation is an even. In order to maintain this equation, we must give a minus 1 to 0. Okay, so in the other words, a equals 1. That's mean I will have q to the n equals 2 to the b minus 1 minus 1. This one is turned 1. Okay, I'm going to find p to the n. I'm simply going to move over this q to the n to the right hand side of this equation. So we'll have q to the n plus 2 to the a. A will be replaced with number 1 here. I will have 2 to the b minus 1. I'm going to replace q to the n with its value minus 1 plus this number 2 here, because 2 to the 1 is giving us 2 to the b minus 1 plus number 1. Okay, so we'll have the second equation. We'll have q to the n equals 2 to the b minus 1 minus 1, and also we'll have p to the n equals 2 to the b minus 1 plus number 1. So I'm going to keep these two equations for later. Now let's move on to the next case. So in the last board we were working on this equation and came up with these two following equations. So now I'm going to consider also 2 more cases when we have b minus 1 is an odd, when we have b minus 1 is an even. Let's start with the odd. If b minus 1 is an odd, okay, since I have q to the n as a first equation equals 2 to the b minus 1 is a congruent to minus 1 to the b minus 1 minus 1. I'm going to use by using the congruence definition. Since b minus 1 is an odd, this minus 1 is turned to minus 1. So we'll have it's congruent to minus 1 with this minus 1 become minus 2. Minus 2 mod 3. I'm reducing this one to mod 3. You might say why this is a congruent to minus 2 mod 3. When we take this one to the left hand side of this equation, for example, if we have 2 to the b minus 1, by taking this minus 2 become with this minus 2 become plus 1. Since this one is an odd, this one it will be written on this form 2 plus 1 factor 2 to the b minus 2 plus 2 to the b minus 3, and so on and so forth until you get the number 1 here. Okay, so this term is divisible by this term. Okay, this is number 3. So if I'm going to reduce this one to mod 3, so I'll get, so is a congruent to 0 mod 3, because 3 divides this one. Okay, then I'm going to add on both sides minus 2, so we'll have 2 to the b minus 1 minus 1, because minus 2 plus 1, which is minus 1, is a congruent to minus 2 there, mod 3. It's taking us to the same result. Okay, now let's continue working on this one. One is telling us 3 not divides q to the n, which is 3 not divides q. Okay, because we have minus 2 here. In order to have 3 divides this one, that means we have 0 here. Let's use the second equation, 1 plus 1. I'm going to do the same thing. This one, I'm going to reduce this one to mod 3. I will have this one is a congruent to minus 1 to the b minus 1 plus 1 is a congruent. Since this one is an odd, this one is toward minus 1, with this plus 1 it becomes 0 mod 3. This one is telling us 3 divides b, because this one is different. We have 0 here, that means 3 divide b. So I have two equations. I will have 3 not divide q, I will have 3 divides p, but the problem, but if you take a look carefully at the original equation, we have the difference of 2 primes is given as positive number. That means p is bigger than q. Okay, but the p is bigger than q. If 3 divide p, what does this mean? This one is telling us p equals 3, because both are primes. 3 is a prime, p is a prime. The only way to get 3 divides p, that means p must equals 3. If p equals 3, eq equals what? Okay, equals 1, which is impossible. If p equals 3, q equals what? Since p is a bigger than q. This is contradiction. It's impossible. What does mean impossible? That means we have no solution on odd numbers. That means we have no solution when we have b minus 1 as an odd. No solution. Now let's move on to the next case when we have b minus 1 is an even. Okay, if b minus 1 is an even. Now we get to the challenge point. Where is the problem start getting complicated? Okay, because we have both equations here. Which equation can take us to the solution? Okay, if you're using the second equation, is taking you to the wrong destination. Okay, because the problem, if you're using the second equation, you are going to use the power of 2, because you are going to take this one to the left, it becomes minus 1. If you consider another 2 cases, n is an odd and is an even, okay, including n is an even, you will have the difference of 2 squares. That means you are going to use number 2 as a power. Okay, that's not gonna help you. We'll find the problem. Okay, because there is p and q are the powers as well. Okay, because they taking priority on number 2. Okay, because both are prime powers. This means we must take the equation number 1 in order to get this one to factored out if we want to take q as a power. Okay, that's what I'm going to do now. I'm going to take the first equation. Okay, so if I'm taking the first equation, we consider b minus 1 is an even. That means b minus 1 equals 2m. Okay, I'm going to replace b minus 1 with 2m. I will have 2 to the 2m. Now I have the difference of 2 squares. I'm going to factor this one out. I will have 2 to the m minus 1 factor 2 to the m plus number 1. Since the left hand side of this equation is a power of q, that means the right hand side of this equation must be a power of q as well. This one will be transferred on the form of the q power. Okay, so we'll have 2 following equation. I will have 2 to the m plus 1 equals q to the j, and 2 to the m minus 1 equals q to the I, where is j strictly superior than I. Okay, when we replace this term with q to the I and this term with q to the j, you will get the exponent n equals 8. You will get the exponent n equals I plus j. So we'll get n equals I plus j. as an exponent. Now I'm going to take the difference of these two equations in order to get 2 to the m eliminated. Okay, so if I'm going to do that, I will have 1 minus 1, which is 2, equals q to the j minus q to the I. So I'm going to take q to the I as a common factor. I will have q to the I will have q to the j minus I minus 1. Okay, if you take a look at the left hand side of this equation, is even. The right hand side of this equation must be even as well, but this term is even. Okay, but this one is odd. Since this one is even, that means it's going to take number 2. Since this one is odd, that means it's taking number 1. That means I goes to 0. Okay, so when it's telling us I must be equal to 0, I have number 2 equals q. I'm going to replace I with 0. We'll have q to the j minus 1. Okay, I'm going to take this minus 1 to the left. I will get 2 plus 1, which is 3, equals q to the j. So this one is telling us j equals 1, okay, as an exponent. That means q is taking number 3. Okay, now I found the value of q as a prime. I found j equals 1. We are able to find m. We are going to use the second equation because we have I equals 0. That means this one equals 1. Okay, by using the second equation, we'll have 2 to the m minus 1 equals 1. Okay, because we're replacing I with 0 here, is giving us 1. By taking minus 1 to the right, I will get 2 to the m equals 2. Now this one is telling us m equals 1. Now we found the value of m. If I found the value of m, that means I found b minus 1. Okay, b minus 1. I'm going to replace m with its value. I will get 2. That means b equals 3. By taking this minus 1 to the right, since I know b equals 3, I'm going to replace it here to find p. Okay, because we already find q is here. So I'm going to use the second equation. So we'll have p to the n equals to b minus 1 will be replaced with 3 minus 1 plus number 1. 2 to the 3 minus 1 is giving us 2. That means we'll have 2 square plus 1, which is 5. But we'll find p to the n. Okay, I found p to the n equals 5. Since p is a prime, that means n equals 1. Now I found the value of n. This means I'm going to replace n with number 1 here, since we have this equation. So we have x equals 2 is multiplied by 1. The value that I found is giving us 2. Now I found x equals 2. I found q. I found p. I need to find y. Okay, now I found p equals 5. I found x equals 2. And I found also q equals 3 with the same exponents too. This one 5 square is giving us 25. 25 minus 9. This is 25, this is 9. That means 25 minus 9 is giving us 16. 16 is will be written on this form, 2 to the 4 equals 2 to the y. Now I found y. Now I found the following solutions. We'll have x equals 2 and y equals 4 and p equals 5 and q equals 3. Okay, now we have done with this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.